Atomic physics. In this chapter, we are going to study the discovery of specific charge of electron, and photoelectric phenomenon, X-rays, etc. Before we go deep into the study of these phenomena, first let us recollect the concepts which we have learned so far. After the discovery of electricity, it led to the experiments of electrolysis. Electrolysis established the electrical nature of matter. That is, it consists of positive and negative charges. So the electrical nature, that is the positive and negative charge nature, is established by electrolysis. Then some experiments were conducted and discharged through gases. The experiments conducted and discharged through gases, they led to the discovery of cathode rays. And on experimentation it was proved they consist of streams of electrons. The experiments on the scattering of particles, alpha particles, from gold foils indicated that the matter is concentrated inside the atom in a small region called the nucleus. So the nucleus concept, it was discovered, it was formulated due to the scattering of alpha particles from gold foils, and it established the orbiting electron nature. The concepts so far discovered are termed as classical concepts. According to classical concepts of electrodynamics, a moving charge in an orbit loses energy continuously. So if the electron is imagined to be orbiting around the nucleus, then it should emit electromagnetic radiation and thereby it should fall into the nucleus. This was the concept of electrodynamics, classical concept of electrodynamics. Then there arose the necessity of formulating stationary orbits, which can only explain the stability of the atom. Then it was formulated that the orbits are stationary, and that can be established only when the angular momentum of the electron is constant. So which was proposed that the angular momentum of the electron in an orbit is an integral multiple of h by 2 pi. Then it was noticed that when energy is absorbed by an atom, the electron goes to the higher energy level, and that is also a fixed energy level, and the atom is said to be excited 1. So when the excited atom, in the excited atom, if the electron jumps from higher energy level to the lower energy level, it gives out energy in the form of photon. So these were the concepts that were developed because of different experiments done in modern physics. Discovery of electron. Before we study the discovery of electron, now let us recollect the phenomenon which we have studied so far. First we studied the discharge of electricity through gases. This happens at low pressures, and this phenomenon led to the discovery of cathode rays. What is meant by discharge? Discharge means passage of electricity through gases. We know that this is possible if the pressure is low and the potential difference is of the order of some 15,000 volts to 20,000 volts. So when the pressure is low and the voltage is from 15,000 volts to 20,000 volts, we notice the discharge, that is electricity passing through gases. Keeping the potential difference to be constant, applying the same potential difference, keeping the potential difference at the high value of from 15,000 to 20,000, if we decrease the pressure, we notice the discharge begins at 10 millimeters, and as the pressure is still decreased, when the pressure reaches to the value of 0.1 millimeters of mercury, the walls of the discharge tube, they exhibit fluorescence, that is some glow opposite to the side of cathode. When such a stage is reached, the entire tube is dark and it is called as Crookes dark space. Crookes dark space. The entire tube is dark except for the glow on the walls. This glow on the walls is caused by invisible particles traveling in straight lines as a stream, and they are called as cathode rays. We have studied the properties of these rays. I shall recollect some of them which will be useful in our experiment now. They are deflected by both electric and magnetic fields. The cathode rays are deflected by both electric field as well as magnetic field. The direction of the deflection of these rays indicate that they are negatively charged particles. And it was noticed that the specific charge, that is E by m, the ratio of charge to mass, is known as specific charge. This value of these particles is the same whatever may be the gas inside the tube. Moreover, they affect the photographic plates. These properties are useful in our study. Thompson's method of determination of E by m of an electron. Here we consider a discharge tube. At the right side we notice the vertical line MP, which indicates the fluorescent screen of the discharge tube. At the left side we notice a resistance wire called filament, the ends of which are connected to a low tension battery to heat the filament in order to produce electrons. And we notice the high tension negative is connected to the filament, and the positive of this high tension is connected to the anode plate A, which carries a hole that coincides with the axis of this discharge tube. Then the horizontal lines with plus above and minus below indicate a capacitor of aluminum plates, and an electric field is indicated from top to the bottom created by the capacitor. And then the horizontal circle, the dotted circle, indicates a coil of wire through which the current is passed in the clockwise direction, and thereby a magnetic field is created into the plane of the screen. That indicates magnetic field created by the coil. Now this is the experimental setup of Thompson's experiment. Working of this discharge tube. An electron beam is emitted by heating the filament with a low tension battery. With a low tension battery, the filament is heated and thereby electrons are emitted. This electron beam passes along the axis of the tube. The electron beam is accelerated with high potential difference given by Ht. High tension gives the sufficient potential to accelerate this electron beam. The beam strikes the fluorescent screen at the point P and produces a speck of light called scintillations. Speck of light called scintillations are produced on the screen at the point P along the axis of the tube. An electric field is applied, creating a potential difference across the capacitor. An electric field is applied by creating a potential difference across the capacitor, and if the upper plate is made positive, the beam deflects in the upward direction and the scintillation point will shift to M. Now the scintillations will be produced at the point M because of the electric field. Then a magnetic field is applied into the plane of the paper by passing current through the circular coil in the clockwise direction. Then by applying this magnetic field once again and by adjusting the magnitude of this magnetic field, the electron beam is brought back to the original position before the position occupied by the beam before electric field is applied, that is to the point P. The spot from point M will be brought back to the point P, original position. This indicates the force due to electric field on the electron is equal to the force due to the magnetic field. The beam has shifted from the point P to the point M due to the force applied by the electric field, and it is brought back from M to P by the application of the force by magnetic field. So the forces are applied in opposite directions by electric field as well as magnetic field. Derivation of the relation for specific charge. Let small e be the charge of electron and small m the mass of electron. Then E by m is called its specific charge. The specific charge of electron is given by E by m, where E is its charge, m means its mass. If capital V be the potential difference applied by high tension, then the energy acquired by the electron is given by EV, because the charge E is subjected to the potential difference V, so that it acquires the energy EV. Because of this energy, the electron is accelerated. This electrostatic energy accelerates the electron, and ultimately it will be converted as kinetic energy of the electron. So if the electron gains a velocity small v, then the energy gained by it is given by half mv square. So electrostatic energy has become kinetic energy. So E capital V is equal to half m small v square. E capital V, this is electrostatic energy, that is equal to half m small v square, that is kinetic energy. From this we get the relation E by m is equal to small v square divided by 2 capital V. So the specific charge E by m is equal to small v square divided by 2 capital V. Let us suppose the electric field intensity is capital E and the magnetic field induction is capital B when the electron beam is undeviated. When the electron beam, the electron particles are traveling with speed v, small v, and they are undeflected under the action of electric field intensity E and magnetic field induction B, then the forces applied by these two fields will be equal. We know that the force due to electric field is capital E into small e. EE is the force due to electric field, and the force due to magnetic field is BeV. B is magnetic field induction, E is charge of electron, and small v is the speed of electron. So BeV is force due to magnetic field and EE is force due to electric field. When the electron travels undeviated, these two forces are equal. So EE is equal to BeV. EE is equal to BeV, from which we will get small v is equal to E by B, capital E divided by capital B. So the speed of electron will be equal to E electric field intensity divided by B magnetic field induction. Let us substitute this value in the above formula for E by m. In the above relation for E by m, let us substitute the value of this velocity of the electron small v as E by B. By substituting the value of v, we get E by m is equal to specific charge is equal to capital E square divided by 2 capital V B square. Specific charge is equal to capital E square by 2 capital V B square. So if you know the electric field intensity, the magnetic field induction, and the accelerating potential, high tension potential, then you can calculate the specific charge of the electron. The results of this experiment, the outcome of this experiment, the value of E by m, that is specific charge, is found to be 1.76 into 10 to the power of 11 coulombs per kg. The specific charge of electron is 1.76 into 10 to the power of 11 coulombs per kg. The specific charge is independent of the material of anode, the material of cathode, the gas inside the tube, the applied voltage, etc. All these factors prove that the particle is a constituent of all matter. It is present in all matter. It is a constituent of all matter. That is, the electron is a constituent of all matter that is pervading. We have studied the determination of specific charge by Thompson's method. The charge of electron was discovered by Electron. The charge of electron was determined by Electron. Now let us see the experimental setup, the apparatus used by Electron for determining the charge of electron. It consists of a metallic chamber. Inside the metallic chamber, two metallic plates are placed horizontally, perfectly horizontally, with some separation in between them. The upper plate carries a hole. Above this hole, an atomizer is fitted above this hole to spray the oil as droplets. The atomizer sprays oil as droplets. Here in the figure, in the left side we see an illuminating source, an intense source of light. In front of it, a convex lens is placed so that the light rays are sent parallel into the chamber, and the space in between the two metallic plates will be illuminated by this light source. So the oil drops will be illuminated and they will appear as bright droplets. Now these oil drops will be observed by using a telescope, which is shown at the right. In front of this telescope, a scale is fitted. A scale is fitted inside the telescope, and we notice, when we observe through this telescope, we notice that the oil drops will be traveling in the vertical direction along this scale. Thus we can observe the motion of the oil drop through this telescope. We have seen different parts of this Electron's apparatus. Now we will study the procedure that is to be adopted in this experiment. Oil will be sprayed as droplets above the hole of the upper plate. Oil will be sprayed as droplets on the top of the upper plate just above the hole. The oil droplets, they descend through the hole into the illuminating space between the two plates. Sometimes these oil drops, they get ionized during the spraying. During the spraying, some of them get ionized. Otherwise, they will be ionized by using other methods. These droplets are illuminated with a monochromatic light, which is shown at the left, and they will be observed through the telescope at the right. The droplets appear to descend along the scale fitted in the telescope. The droplets appear to descend along the scale fitted in the telescope. By applying an electric field, we can make it move in the upward direction also. We measure the distance traveled by a droplet. We measure the distance traveled by a droplet in a specified type, and thereby we calculate the speed of the particle. So we can measure the speed of the oil drop inside this chamber. Now let us study the motion of the oil drop under gravity when there is no electric field. the oil drop descends in the downward direction. It moves in the downward direction under the action of gravity. And the forces acting on this oil drop are gravitational force mg the downward direction, viscous force Fv in the upward direction, and buoyancy force Fb in the upward direction. Three forces act on this oil drop: gravitational force, viscous force, and buoyancy force. Viscous force and buoyancy force, they act in the upward direction, and gravitational force acts in the downward direction. Remember that gravitational force always acts in the downward direction and buoyancy force always acts in the upward direction. Viscous force acts opposite to the direction of motion. Here the oil drop is descending, hence the viscous force acts in the upward direction. Now let us assume that the radius of the oil drop is small a. Let us assume that the radius of the oil drop is small a and the density of the oil is rho. The density of the oil is rho. Then the weight mg becomes equal to 4 by 3 pi a cube rho g. 4 by 3 pi a cube is volume of the drop, into rho density gives mass of the drop, into g acceleration due to gravity. So mg becomes equal to 4 by 3 pi a cube rho g. If sigma is the density of air, then buoyancy force is given by 4 by 3 pi a cube sigma g. Buoyancy force is given by 4 by 3 pi a cube sigma g. 4 by 3 pi a cube is volume of the air displaced, into sigma gives the mass of the air displaced, into g gives the weight of the displaced air. That acts as buoyancy force. If eta is the coefficient of viscosity of air, then from Stokes' law the viscous force Fv is given by 6 pi eta a into Vg, where Vg is the terminal velocity of the oil drop. If the oil drop descends with constant velocity Vg, known as terminal velocity, then from Stokes' law we can get the value of viscous force Fv as 6 pi eta a Vg. Now the resultant force on the oil drop is 0 if it is descending with uniform velocity. If the oil drop descends with uniform velocity, the resultant force on the oil drop is 0. Therefore, the relation between the forces acting on the oil drop is mg is equal to Fv plus Fb. mg is equal to Fv plus Fb. mg is downward force and Fv, Fb are the upward forces. So the algebraic sum of these forces is 0. So mg is equal to Fv plus Fb. Let us substitute the values as derived above. So we will get the following relation: 4 by 3 pi a cube rho g will be equal to 4 by 3 pi a cube rho g is equal to 4 by 3 pi a cube sigma g plus 6 pi eta a Vg. 4 by 3 pi a cube sigma g plus 6 pi eta a Vg. From this relation, by taking 4 by 3 pi a cube sigma g to the left side and rearranging, we will get 4 by 3 pi a cube into rho minus sigma into g is equal to 6 pi eta a Vg. 4 by 3 pi a cube, pi gets cancelled. So 4 by 3 a cube, 4 by 3 a cube into rho minus sigma into g is equal to 6 eta a Vg. 6 eta a Vg. This is the relation that we get when the oil drop is descending under gravity. We have derived a relation when the oil drop is descending under gravity with uniform velocity. Now let us derive a relation when the oil drop is ascending with uniform velocity. This can be achieved. A uniform upward velocity can be achieved by applying an electric field. For example, if the upper plate is made positive and if the oil drop is carrying negative charge, then the electric field is created in the downward direction and the oil drop moves in the upward direction. Suppose the oil drop is moving up with a constant velocity VE under the action of an electric field of intensity capital E, and let us suppose the charge on the oil drop is small e. Let the electric field intensity be capital E and the charge on the oil drop is small e, and the oil drop is moving up with uniform velocity VE. Now the forces that are acting on the oil drop are mg, weight in the downward direction, Fv, viscous force in the downward direction. We know that the viscous force always acts opposite to the direction of motion of the body. Since the oil drop is ascending, the viscous force acts in the downward direction. So the downward forces are weight and viscous force. The buoyancy force acts in the upward direction. It always acts in the upward direction. And in this case, the electric field force is also acting in the upward direction. This electric field force, Fe, is acting in the upward direction and buoyancy force is acting in the upward direction. Since the resultant force on the oil drop is 0, the sum of upward forces is equal to sum of downward forces. The relation between the forces is sum of the downward forces is equal to sum of the upward forces. So we can write the relation between the forces as Fv plus mg is equal to Fb plus Fe. Fv, viscous force, plus mg, weight, is equal to Fb, buoyancy force, plus Fe, force due to electric field. Now let us find the values of different forces. The gravitational force mg is equal to 4 by 3 pi a cube rho g. Gravitational force mg is equal to, this we have already derived, 4 by 3 pi a cube rho g. And the viscous force Fv is equal to 6 pi eta AVE. Viscous force Fv is equal to 6 pi eta AVE. Buoyancy force Fb is equal to 4 by 3 pi a cube sigma g. Buoyancy force Fb is equal to 4 by 3 pi a cube sigma g. And electric field force Fe is equal to EE, capital E into small e. Substituting the values of these forces, we get 6 pi eta AVE, 6 pi eta AVE plus 4 by 3 pi a cube rho g, 4 by 3 pi a cube rho g is equal to 4 by 3 pi a cube sigma g plus EE. 4 by 3 pi a cube sigma g plus EE. Rearranging this equation, we get the following equation. 4 by 3 pi a cube into 4 by 3 pi a cube into rho minus sigma into g is equal to minus 6 pi eta AVE plus EE. 4 by 3 pi a cube into rho minus sigma into g is equal to minus 6 pi eta AVE plus EE. This is the relation that will be obtained when the oil drop is moving up with uniform velocity. Now let us derive the relation for charge on the oil drop, a relation for small e. Let us make use of the relations that we have derived when the oil drop is descending under gravity and it is ascending under the action of an electric field. When the oil drop is descending under the action of gravity, the relation that is obtained is 4 by 3 pi a cube into rho minus sigma into g is equal to 6 pi eta a Vg. Once again, 4 by 3 pi a cube into rho minus sigma into g is equal to 6 pi eta a Vg. When the oil drop is ascending with uniform velocity, the relation that is obtained is 4 by 3 pi a cube into rho minus sigma into g is equal to minus 6 pi eta a Ve plus Ee. While the oil drop is ascending, the relation obtained is 4 by 3 pi a cube into rho minus sigma into g is equal to minus 6 pi eta a Ve plus Ee. The left hand side of these two equations, we get the same term. The same term is there on the left hand side. So the right hand side terms must be equal. Therefore, we can write the equation as minus 6 pi eta a Ve plus Ee is equal to 6 pi eta a Vg. Minus 6 pi eta a Ve plus Ee is equal to 6 pi eta a Vg. Therefore, E is equal to, small e is equal to 6 pi eta a into Vg plus Ve whole divided by capital E. The relation for small e is equal to 6 pi eta a into Vg plus Ve whole divided by capital E. From the first equation, the radius a is given by the value of a will be obtained in terms of eta, Vg, etc. as a is equal to 9 by 2 into e. The derivation in a nutshell. How to remember this derivation? The simplest way is, first obtain the relation for the oil drop when it is freely falling, which is 4 by 3 pi a cube into rho minus sigma into g, that is equal to 6 pi eta a Vg. And when the oil drop is ascending with uniform velocity, the relation that will be obtained is 4 by 3 pi a cube into rho minus sigma into g is equal to minus 6 pi eta a Ve plus Ee. From these two relations, since the left hand sides are equal, the right hand sides must also be equal. So equating, we will get minus 6 pi eta a Ve plus Ee is equal to 6 pi eta a Vg. So E is equal to 6 pi eta a into Vg plus Ve divided by capital E. The value of a from the first relation will be obtained as 9 by 2 into eta Vg divided by rho minus sigma into g whole to the power of half. By remembering these values, we can derive the relation. Importance of Millikan's experiment. The charge of electron is determined accurately for the first time. The charge of electron is determined accurately for the first time by Millikan's experiment. It was noticed that the charge E, the charge of the electron, E is the smallest available possible charge, smallest possible quantum of charge. Moreover, the charge at any body is found to be an integral multiple of this small unit. For example, if Q is the charge on a body, then Q is equal to Ne, where N is an integer. So this proves the quantization of charge. The specific charge of an electron is already determined as 1.76 into 10 to the power of 11 coulombs per kg. We can determine the mass of electron with the charge and specific charge. We know E is charge and E by M is specific charge. So E divided by E by M is equal to M. Charge divided by specific charge gives the mass of electron. Using the values of charge and specific charge by calculation, the mass of electron is obtained to be 9.1 into 10 to the power of minus 31 kgs. 9.1 into 10 to the power of minus 31 kgs.